Today, we're going to talk about private AI. We're looking at a really powerful team up between two huge technologies, federated learning and blockchain. We're going to see how they combine to create an AI that's not just incredibly smart, but one we can actually trust.
So, think about this for a second. How can an AI learn from all the sensitive, private stuff on your phone or in a hospital's records without actually seeing any of that raw data? It sounds impossible, right? Well, the answer is the first key to our puzzle, and it's a revolutionary idea called federated learning. Okay, let's break this down. Federated learning, or FL for short, is a super clever way to train one big, central AI model without ever having to move sensitive data off the device where it lives. Think of it like a bunch of students studying from their own secret notebooks. They never share the notebooks, they just share the lessons they learned. That's the key here. So here's our game plan for this explainer. We'll start with the incredible promise of this privacy-first AI. But then, we're going to hit the roadblocks, the critical flaws. And that's when blockchain steps in as the missing piece. We'll see how this new partnership creates a way more secure system. And finally, we'll look at what all this means for the future of AI we can actually trust.
All right, first up, let's talk about the dream, the big idea behind federated learning and why so many people got so excited about it in the first place.
The traditional process is actually pretty simple when you break it down. First, a central server sends out a kind of starter AI model to maybe millions of devices, like all of our phones. Then, step 2, your phone takes that model and trains it using only your local data, like how you type, to get better at predicting your next word. And here's the magic. Your personal data never ever leaves your phone. Finally, the phone just sends back the learnings, these tiny anonymous updates. The central server then averages all these little updates together to build a much smarter global model for everyone. So on the surface, this looks amazing, right? A perfect system for privacy. And it really was a huge leap forward. But there's a catch. A pretty big one, actually. As researchers started poking at it, they found a critical weakness, a single point of failure that could bring the whole thing crashing down.
And that brings us to the big problem. So what exactly is this fatal flaw? Well, it all boils down to that one piece of the puzzle, the central server. And yeah, this really says it all. The entire system, the model distribution, collecting the updates, putting them all together, everything flows through one single point. And when you put all your eggs in one basket like that, well, you've created the system's Achilles heel. Having that one central hub is like painting a giant bullseye on it for attackers. I mean, look at this list. If that server goes down, the whole network is kaput. That's your single point of failure. It can get totally flooded and knocked offline with a denial of service attack, or, and this one's really sneaky, it can be tricked by bad actors sending in corrupted updates to deliberately poison the AI. Okay, so let's zoom in on those poisoning attacks, because they're a huge problem. You've got an honest device, right? It does its homework and sends back a helpful update that makes the AI smarter for everyone. But then you have a malicious actor. They send back a deliberately messed up or poisoned update. Now, if that central server doesn't catch it, and that's a big if, that poison gets mixed into the global model, making it dumber, less accurate, or even biased. It's bad news. And you don't have to take my word for it. The research is crystal clear on this. Kumar and his colleagues put it plainly. The reliance on a central server is the problem. So the billion-dollar question becomes, how do you get rid of that single point of failure? Well, this is where our second technology enters the stage. Blockchain offers a radically different, decentralized approach. So let's really get what this means. The old centralized system is like a bank vault. All the valuables are in one place, making it a high-stakes target. A decentralized blockchain, on the other hand, is like a magical shared ledger. Everyone has a copy, and any change has to be agreed upon by the group. There's no single vault to rob. And this table just lays out the transformation perfectly. I mean, look at this. We go from a vulnerable centralized server to a robust decentralized network. We gain an immutable, tamper-proof history of every update, which makes those poisoning attacks much easier to trace. Trust is no longer placed in a single company's server, it's established by math across the whole network. And this is a real game changer. We can even build in rewards to incentivize people to contribute high-quality updates. Okay, so what does this new secure partnership actually look like? Let's break down the new workflow step by step. The fundamental change is this.
we completely get rid of the central server. It's gone. In its place, we have a network of participants, often called miners, and their job is to validate and aggregate the updates, all governed by automated rules called smart contracts. So here's the new workflow. Step 1's the same. Devices train models locally. But in step 2, instead of sending updates to a server, they send them to the network of miners. The miners then verify and aggregate the updates. And step 4 is absolutely crucial. They run a consensus algorithm. Think of it as a cryptographic voting system to collectively agree on the one correct version of the global model update. This makes it incredibly difficult for a bad actor to corrupt the system. Once they agree, that new global model is sealed into a new block on the blockchain, creating a permanent, trustworthy record. Finally, anyone can securely download the new, verified model. So what is the payoff for all this? What does this new future of trustworthy AI really mean? Well, the benefits are immense. First, enhanced security. Get rid of the central server, you get rid of the single biggest target. Simple as that. Second, improved trust. Every single update is permanently recorded on the blockchain, creating a tamper-proof audit trail. This leads to real accountability. If someone does try to poison the model, there's a permanent record. And finally, you can build in automated incentives like crypto rewards to encourage participants to contribute high-quality, honest updates.
And this isn't just a theoretical idea. The academic world has taken notice. Look at the explosive growth in research papers on this exact topic. From less than 200 in 2019 to over 2,000 in 2021. This shows a massive surge in interest and proves just how important this new partnership is. Of course, it's not a silver bullet just yet. This is still an evolving field. Researchers are actively working on challenges, like how to handle malicious miners who might try to cheat the system, or how to manage the complex timing and synchronization of all these moving parts. But the consensus is clear. The source for this explainer, a systematic review of 41 recent studies, came to a powerful conclusion. Integrating blockchain with federated learning isn't just an interesting idea. It provides a fundamentally more secure and robust foundation for the future of AI. Which leaves us with a final, fascinating question. As we rely more and more on AI, the need for trust becomes paramount. By combining the privacy of federated learning with the security of blockchain, we have to ask, are we looking at the blueprint for a future where our AI is not only powerful, but provably private and fundamentally trustworthy?